All right, so here's an example. This is like what we're going to be looking at. And notice that we have a situation where a is greater than 1, right? And, we always want to check for a GCF first. That's always the first step in factoring any kind of polynomials. But in this case, we don't have a GCF. And in fact, on this whole assignment, I'll tell you that we're not going to have GCF. So I just want to focus on the skill of factoring complex quadratics. And then the next assignment, we'll bring back in GCFs and some of the different types of factoring and kind of practice with them all together. Okay, but for this lesson, I just want to focus on factoring out or factoring complex quadratics. Okay, so remember that quadratics or trinomials that we're going to be able to factor in this way have this form generally. Okay, so you have ax squared plus or minus bx plus or minus c, and a, b, and c will be integers, of course. And then, of course, the signs where you see the plus minus is there, those could change, right? And depending on what those are, they have implications as far as our strategy and our process, okay? All right, so the first step I have here is factor out the GCF and make a positive, right? So you always want the leading coefficient to be positive when you're doing this factoring method. But for today only, we're gonna not worry about that one, okay? I'm gonna keep it in there, but we're not going to be worrying about the GCF today, okay? All right, so the first thing is we're going to multiply a by c. So we're going to multiply, in other words, the first term, the leading coefficient, the one with the x squared, by the last term, which is the term that usually doesn't have an x, right? Or doesn't have a variable. But remember, there are times when it has a squared variable, and so sometimes you have two variables. But anyway, basically multiply the first term by the last term. So let's do that with number 1. So I'm going to multiply 4 times 56. Okay. And let's see, I'm going to get 224. Just do that on my calculator, right? I get 224. Okay. So now I want to make a list. I'm actually going to write it down here below 224. So now I want to make a list of factor pairs, okay? Because what I want to do next is I want to step B, and this is the step that we kind of went over in the last example, and I was showing you factor pairs. So we want to find two factors, so another factor pairs of AC, so this number that we just found here, that have a sum or difference of B, okay? So B is this middle number, okay? So let's do that. Let's read it in terms of what we have in our problem. So I want to find two factors of 224 that I can add to get 39, okay? So two numbers I can multiply to get 224 that I can add to get 39. All right. So we're no longer looking at just C, right? We're looking at this product here. And then from there, it's going to be very similar to simple quadratics. But this is the harder part because we're going to have a bigger number here, right? So they're not going to be numbers that we are as familiar with. And so that's why we make our list. Okay. Now, one trick is instead of starting at 1, I could do 1 and 224 and all that. But you can also start with the numbers that you just use to multiply, because usually you're kind of closer to the middle. So I'm going to actually start with 4 and 56. Okay. And I want to add to get to 39. So 56 plus 4 is 60, right? So that number is too high. And so I want to get a lower number. So the way you get lower numbers is by bringing these closer together. Okay. So in other words, I want to get a bigger number than 4 and a smaller number than 56. Okay. Bigger than 4, smaller than 56. And that'll get me a smaller sum or difference, actually. Okay, so I'm going to check, does 5 go in? And the answer is no, it doesn't, right? This number doesn't end in a 5 or 0, and so 5 doesn't go in. Does 6 go in? 224 divided by 6 is a decimal, so 6 does not go in. Does 7 go in? Yeah, it happens to go in. 224 divided by 7 is 32, right? And here we go. 7 plus 32 is 39. Okay, so there we have our winners, right? Ding, 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 ding. We have our winners. So those are our values that give us our two factors of 224 that have a sum in this case, right, of B, which happens to be 39 here. Okay, and I said just to help us with this process here, I call them P and Q. So we have P and Q here, right? Okay, And so now we're gonna set them up like we would with a simple trinomial. Okay. So what I'm going to do is I'm going to open up parentheses here, and I'm going to put an x here and an x here, and then I'm going to put the 7 and the 32 in here. Okay. Now, here's the next part: is we want to get the appropriate signs, right? So if I want to have a sum, if I want to add them, or in other words, if I want to, let's say if I want to add them, I know the sides need to be the same, right? So this tells me if this is positive, the signs are the same. Okay, and then if they're the same, remember this is the sign of the bigger number, so 32 is going to be positive. And if the signs are the same, this other one's also going to be positive. Okay. Now you might be thinking, okay, Mr. Gloyd, this is not going to work because 7 times 32 does not equal 56, right? And x times x does not equal 4x squared, and you're definitely right. So here's kind of the magic part, right? And I learned this from a middle school teacher, and I think it was Edgewood, that I was observing one time, and she had this method in it. I was very thankful to have learned it after the other ways that I had known before. So, but anyway, what you're going to do next is you're going to take whatever a is, okay? You circle it in purple. So whatever a is, you're going to put that and make it the denominator, okay? And then you're going to reduce. So here, if I reduce 32 or 7 over 4, that doesn't reduce, okay? And 32 over 4 reduces to 8 over 1, right? Okay, and so the next step is whatever you get, whatever your new denominators are after you reduce, you're going to bring those to the front, in front of x, okay? And so here we end up with 4x plus 7. And here we end up with 1x, or just x, plus 8. And that's our final answer, okay? So definitely a longer process than we're used to seeing with some of the other types of factoring. But I'll tell you once again that this method is a lot nicer than some of the methods that I've seen and used before. And so it's more systematic, more straightforward than all the other methods that I've seen. Trial and error works sometimes, especially with smaller numbers. And you're welcome to use that if the numbers are smaller. But I definitely recommend a systematic way when you have some bigger numbers like 56, okay? Because trial and error, there's a lot of ways you can do it. To get 4, you can multiply 2 times 2, 4 times 1, 1 times 4, right? To get 56, there's a lot of different factor pairs, and so this is a good way to do it. Now, back to this just for a second. Remember that if this didn't make sense starting in the middle here with 4 and 56, you can do make your whole list, right? 1 and 224, 224, 2 and 112, 3 doesn't go in, 4 and 56, right? And then you can keep going from there. And once you get to a set that works, then you can stop, right? But and the other thing is you can keep going and get to the end of your list. And if you don't find any, remember, if you get to the point where you get to a number on this side that's already on the other side, that means your list is done. And if you don't find numbers that add or subtract to get to that middle number, that means it's a prime. Complex quadratic. Okay. All right. And then the last thing, let me just show you the last few steps here. We talked about them, but just so if you want to write these down in your notes. So this is the complete list of sets, or complete list of steps here, I should say. And so you set it up like you would a simple quadratic, right? Put in the P and the Q in there. You get your signs right depending on what these signs are here, right? These signs are the ones that kind of dictate what your signs here and here will be, just like a simple quadratic. Sign of the bigger number is the sign of B. The sign of C tells you if the signs are the same or different, okay? But then the two funky steps here at the end are where you put A in the denominator, and then you reduce the fractions, and then you bring the simplified denominator to the front. Okay, only after you simplify it, you bring it to the front. All right. Cool. So we'll do some more examples, and hopefully this will make a lot more sense as we go. Okay.